Hello everyone, welcome to another video on integration, and in this video I would like to talk about the integration of definite integrals. So our first integral is the integral from 1 up to e of open brackets 18 minus 6 natural log of x close brackets open 2 plus natural log of x close all over 37x dx. So we're supposed to evaluate this integral. Now if you look at this integral, it's very tempting and inviting to think that expansion of the numerator is the way to go. However, if you try to expand the numerator, you see that it will actually lead you to the square of the natural log of x, which is very difficult to integrate. So therefore, expansion of the numerator is ruled out. So where do we go from here? So this is another case of a higher order u-substitution type of integral. But the first thing we have to note is that we have 18 minus 6 natural log of x. So there is a common factor there which can be taken out. The common factor is 6. We have to get rid of that first. Take it out. So that will be our starting point, and then after that we're going to look at u-substitution. I promised you that I was going to come up with questions involving advanced cases, even more advanced cases of u-substitution. This is one such example. So let's look at the solution then. Our answer will be as follows. Our answer, so question 1, it says the integral from 1 up to e of 18 minus 6 natural log of x, and then we have 2 plus natural log of x all over 37x dx. Now, like I told you, we factorized the first bracket there. Our common factor is 6. So this is equal to the integral from 1 up to e of 6 open brackets. 6 into 18, that's 3, minus 6 into 6 natural log of x is natural log of x. This is what we have, 2 plus natural log of x all over 37x dx. Now notice that 6 and 37 are constants, and 37 is dividing, 6 is multiplying. So I'm going to take these two out, and then I'm going to put x together with dx as follows. So this is equal to 6 all over 37, the integral from 1 up to e, watch this, of 3 minus natural log of x, and then we have 2 plus natural log of x times dx all over x. Right, now we are okay. At this stage, we're going to look at these two brackets. The first one has a minus sign, which means the natural log is negative in the first bracket, but in the second bracket, the natural log is positive. So I'm going to let this be equal to u. So at this stage, I'm going to say let u be equal to 2 plus natural log of x. And I'm going to differentiate u with respect to x, and then take the dx on the other side. But let me just take it slowly. So du dx is actually equal to derivative of 2 is a constant, derivative of natural log of x is just 1 over x. Now I have to multiply this both sides. So what do I get? I get du will be equal to this multiplied by dx. Notice I'm just going to get dx all over x. So that part there is taken care of. You can see that part will be replaced by du, and this part here will be replaced by u. My job is that part. So that means out of this equation here, I must produce that. In other words, I must express this in terms of u. I told you this is a very advanced case of u-substitution. So we carry on, we continue as follows. We're on page 2 now. Let me just take that forward. I said out of u is equal to 2 plus natural log of x, I must produce 3 minus natural log of x. So the first thing I'm going to do is to check the 2 to the left hand side, so I remain with natural log of x, and then I'm going to multiply by minus 1 both sides. So this implies u minus 2 is equal to natural log of x. So now we have natural log of x, which is this part here, but it's negative, so I have to multiply the whole equation by minus 1. So this means this becomes minus u, and then plus 2, this will be equal to minus natural log of x. Fantastic. Now if you notice, I have managed to obtain the first part. Now I need this. So this 3 is positive, I'm going to have to add 3 on both sides. So now I'm going to say this is the same as minus u plus 2 plus 3 will be equal to minus natural log of x plus 3. Rewriting this, you'll agree with me that this is just 5 minus u. And on the right hand side, you have 3 minus natural log of x. Fantastic. Now you can see that this is also taken care of. So that is taken care of, that is taken care of, and that is taken care of. Because this place here, I'm going to put u. In that place, I'm going to put du. And here, I'm going to put 5 minus u. But now I have one more problem. The problem I have now is I want to introduce a new variable u. But the limits of integration are with respect to x. So I have to change the limits of integration now. So I'm going to come back to this equation here, and I'm going to say that equation is u is equal to 2 plus natural log of x. Now I'm going to say as x approaches, the lower limit is 1. As x approaches 1, u must approach what? It must approach 2 plus, remember we're putting 1 here, natural log of 1. We all know that this will be 2 plus natural log of 1 is 0, and the answer is just 2. That will be our lower limit with the variable u. Now we have to take care of the upper limit. So we're going to say, and as x approaches, the upper limit is e. As x approaches e, u must approach what? It must approach 2 plus natural log of e. 2 plus natural log of e. And we all understand and know that 2 natural log of e is just 1. And the answer is 3. Now we are fine. We must go back now to our integral. This integral now changes to 6 over 37. The integral of instead of 1, I'm going to have the lower limit of 2 all the way up to 3 of this, remember, is 5 minus u, and this part here is going to be u, as you can see here. U equals 2 natural log of x, or even here, u equals 2 natural log of x. Now, let's go to page number 3. Page number 3 will be as follows. Now, on page 3, we're now going to say our integral now must change. So, we're now going to say, am I fine? Yes, I'm fine. So, we're now going to say this is equal to 6 over 37, the integral from 2 to 3, like I told you. And the first part here, that part must be replaced by this expression, 5 minus u. And that part there must be replaced by u. So now I have 5 minus u, and then du. So this is 5 minus u, and then times u, and then I have du. Now you see how we've managed to get rid of the natural log, and we have a wonderful integral to deal with. Now let's carry on. So we're going to expand that. Now I'm going to keep the constant outside, 6 over 37, and I'm saying the integral from 2 up to 3 of 5u minus u squared. You distribute this u, and we have du. Now I'm going to keep this one outside, and I'm going to distribute the du and the integral. So I'm going to say this is equal to 6 over 37, and I'm going to, let me open a bigger bracket here, and I'm going to say the integral from 2 all the way up to 3, keep 5 out because 5 is a constant, of u du, minus, check this out, the integral from 2 to 3 of u squared du. And then we close that bracket like so. Now keep this one outside. So this is 6 over 37. And then we have 5. The integral of u, let me introduce new brackets here, round brackets. Integral of u is u squared all over 2. Remember, this is power of 1. 1 plus 1 is 2, and we have to divide that. And this is evaluated from 2 all the way up to 3. Let's cross bracket there. Minus, we are here now. The integral of u squared is actually u power 3 all over, remember, 3. And we introduce another set of brackets here. This is evaluated from 2 up to 3 also. 2 up to 3, close brackets, and then we can close the square bracket there. Like so, in a space there, a bit of a problem, but you can see what I'm trying to say. Now, let's work on this and that. Now, we have 6 over 37 outside, and we still have 5 there. Keep it there, and then we're going to say open brackets. 3 must come in that place. It will be 3 squared all over 2. And then minus 2 must come into that place. It will be 2 squared all over 2, and we close bracket. Right, take note of that. We put 3 there. It will be 3 squared all over 2, because that's our denominator. And then we take 2, put it there, and this is what we have. Now minus here, we put 3 there. If I may write it here, because of space, it's going to be 3 cubed all over 3 minus, remember 3 there, and then we take 2 into that place. It will be 2 cubed all over 2, all over 3, sorry, all over 3. And we're going to close brackets like this, and then we close the square bracket. Now we're almost there. So this is 6 over 37, and we still have a 5 outside, open brackets. That would be 9 over 2 minus 4 over 2. I'm not going to simplify that. So 9 over 2 minus 4 over 2, close brackets, minus, open brackets. This I'm also not going to simplify it. This is 27 over 3 minus, and that is 8 over 3. I'm not going to simplify that because the denominator is the same. Right, let's go to page number 4. On page 4, what do we have? We have on page 4, carrying on, very sweet kind of problem here. This is going to be 6 over 37, and we have now 5, open brackets. If you check there, we subtract numerators, it will be 5 over 2. Then minus 27 minus 8, it will be 19. If you notice that, it will be 19 over 3, like this. And then we simplify that. This will be 6 over 37, and then we have 25 over 2 minus 19 over 3. Now I'm going to make the denominator the same here. How do I do that? Multiply by 3, multiply by 3, multiply by 2, multiply by 2. So what do we have? Now we're going to have 6 over 37, open brackets. That will be 75 all over 6 minus, that will be 38 all over 6. Now again, denominator is the same. We just subtract the numerators. 75 minus 38, it will be 37. So now we have 6 over 37. Now we can say times 37 all over 6. Look at how nice this is. What are we saying? Our final answer is 1. That's the final solution to our first integral. Right, how many pages have we covered this? 4 pages. I told you, I promised I was gonna bring up questions that are quite involving. There is where we started from. You can see it from there. Factorization and where to change from natural log to simple integral. This one here. And then we went on with integration until our final solution is 1. Right, so this is our first integral. Let's look at the second one. The second one is also just as challenging, and we will be able to handle this one just a little bit of a different approach, but same understanding. Now here we go. This is our integral number 2. We're supposed to evaluate the integral from 1 up to 19 over 7 of minus 5 all over x squared plus x minus 6 dx. Now we are back to the denominator being a trinomial or a quadratic function. Now if you look at this quadratic function here, the first question we ask, techniques of integration 2, I have given you that explanation, and 3 as well as 4. The first thing you have to ask yourself is, can I factorize that? If you can't factorize it, look at the numerator. Do I have x? If this is x squared, do I have x in the numerator? If you don't have x in the numerator, you are going to think about trig substitution, which will come up in my next video. But in this one, likely the denominator can be factorized. Now, and I'm going to show you how we do it. Now, because we can factorize the denominator, we know we're going to use partial fraction decomposition. So let's go on and tackle this one. So number 2. So number 2, it says the integral from 1 up to 19 over 7 of minus 5 all over x squared plus x minus 6, and we are saying dx. Now, factorizing the denominator, I want to do it on a separate page just to remind you Mathematics is continuous. Do not ignore the fact that you have to remind yourself of how to factorize quadratic expressions, and sometimes it will be cubic expressions and so on, where you would be required to use remainder and factor theorems. But in this case, we have, and I want to answer it here, we have x. I think that one is a little bit not very clear. Let me use my other marker. So we have x squared plus x minus 6. How do you factorize this? Well, you take this one here, multiply by that. The answer is minus. I'm going to write it down here. It's minus 6x squared. Remember, that is called product. The sum is going to be positive 1x in the center there, positive 1x. Now, when you're counting, you start from 1. So 1 into 6, the answer is 6. Because the product, we call this product, remember? Why is it called product? Because we're multiplying those two. And this is called the sum. That one. Sum of what? Two factors. Whose product is this and whose sum is that? The sign here is negative. These signs here must be different. So we have that. And then I add these up. The answer is going to be minus 5. I add these up, positive 5. And I'm looking for positive 1. From 1, where do I go to when I'm counting? I go to 2. 2 into 6, the answer is 3. The sign here is minus. The signs here must be different. And I have this. When I add those up, I get minus 1. When I add these two up, I get positive 1. And that's what I'm looking for. So I put x, and I know there's x there. This is that one there. It means these two terms must come into the center as follows. So we're going to say now this is equal to x squared. Instead of x, I'm going to put minus 2x plus 3x minus 6. I'm going to put these two terms, these two, in the center there. And then now I'm going to use grouping terms. So I group these two terms and I group those two terms. The common factor there you can see is x, open brackets, x into x squared, x into minus 2x minus 2, plus common factor there is 3, and then we have x minus 2 as well. So you can clearly see that the common factor is x minus 2, and then the other bracket must contain x plus 3, these two into the other bracket. So that completes factorization of this trinomial here. So remember, I have x minus 2 and x plus 3. So now we can rewrite this then to, we can rewrite to this one to the integral from 1 up to 19 over 7 of minus 5 all over x minus 2 and then x plus 3 dx. Now we have two linear terms multiplying in the denominator. So partial fraction decomposition, I'm going to do it on this page here. So we're going to say now minus 5 all over x minus 2 and then x plus 3. This can be simplified because we have linear here. The numerator will be a constant, x minus 2, and then we have plus b all over x plus 3. And then we simplify the right hand side. So what is the common factor? I mean the common denominator, the lowest common denominator. It's going to be just the product of the two. So x minus 2, and then we have x plus 3. Now this one here into that, of course these two cancel, you're left with that. So that has to multiply by the numerator, this one here. So we're going to say a, open brackets, x plus 3, close brackets, plus this one here into that, where these two cancel. Remember here I said this cancels that, I'm left with this. This had to multiply by a. Now this into that, these two cancel, I'm left with this. It has to multiply b. So b, x minus 2, like so. Now, let me move backwards a little bit because of space, and I'm going to expand the numerator. So now I have ax plus 3a, and then I have bx minus 2b all over the denominator. Remember, this is x minus 2 and then x plus 3. Now, so what is this equal to? It is equal to minus 5 all over x minus 2 and then x plus 3. Clearly, you can see when two fractions are equal, and it turns out that the denominators are equal, numerators must be equal. These two are equal, the denominator here, denominator there, we're going to equate numerators. On page 6, we're going to say on page 6, we're going to say there, this implies minus 5 is actually equal to ax plus 3a and then plus bx minus 2b. That's what we're going to say. Now I want to rewrite this, and I'm going to rewrite the terms on the right hand side. These two terms here are like terms, and those two are constant values, must be put together. But this one, I'm going to rewrite it to, watch this, to 0x plus minus 5. Watch, this number here is the same as that. Why am I writing it this way? Because on the right hand side, if you like, we have a plus b x. If you take these two, factorize common factor x, and then I'm going to have plus 3a minus 2b. That tells you I must now equate coefficients. So 0 is equal to that. So a plus b equals 0. That's equation number 1. And then I'm going to say 3a minus 2b equals minus 5. 3a minus 2b equals minus 5, equation number 2. Now, the way we solve these equations, you can see I have a plus, a minus here. I'm going to have to make sure the coefficient there is 2, so I can just add, and b is eliminated. So I'm going to have to multiply the top equation by 2. So I'm going to have 2a plus 2b is equal to 0. And then I'm going to have 3a minus 2b equals minus 5. So I simply add these equations up. 2a plus 3a is 5a. Positive 2a minus 2b, positive 2b minus 2b is 0, and 0 plus minus 5 is minus 5. Divide by 5 both sides, a equals minus 1. Fantastic. Now we have to find the value of b. Now, how do we find the value of b? We go back to equation number 1. What does equation number 1 say? Equation number 1 says a plus b equals 0. What is a? A is minus 1. Minus 1 plus b equals 0. Clearly, b equals 1. Now we have constant values of a and b in that part there. So that means this integral here can be changed. Instead of having this, I'm going to have minus 1 over x minus 2 plus 1 over x plus 3. Because b is 1 and a is minus 1. Right, so let's go to page 7 then. So on page 7, we can say, yeah, you can still see what I'm writing. So we can say, therefore, now we have the integral, watch this, from 1 up to 19 over 7. In brackets, now I'm going to have minus 1 over x minus 2 plus 1, yeah, over x plus 3. And then I have dx. Now, this has been changed. Remember, a is minus 1. We got a as minus 1. Here it is. A is minus 1. And b, we got it as 1. So we have to change that to minus 1 and 1 and put it in there as shown here on this page. Shown on this page here. Right. There we go. Now, continuing here, I'm going to distribute this and distribute the dx. So we're going to say this is equal to the integral from 1 up to 19 over 7 of minus 1 over x minus 2 dx. Let me put this in brackets like so. And then plus the integral from 1 up to 19 over 7 of what? Of 1 over x plus 3 dx. Space there, but you can see I'm writing dx there. Now, this part and that part, how do I integrate this? I'm going to move backwards for the sake of space. At this stage, if you have watched my previous videos, you can clearly see that minus can be taken out. So we're now going to say this is going to be minus the integral of 1 up to 19 over 7 of 1 all over x minus 2 dx, and then plus the integral, check this out, this part here, it will be, of course, the way it is, the integral from 1 up to 19 over 7 of what? Of 1 all over x plus 3 dx. Now, we're supposed to integrate these two. If you use u-Substitution, which I'm going to show you on a separate page, this simply gives us, I would actually use u-Substitution, but I don't want to change the limits. So we can just, because these are very simple fractions, we can just go on and say this is the same as minus, check this, and I'm going to put open bracket here for that one, natural log of x minus 2, and we're evaluating it from 1 up to 19 over 7. And then we have like so, plus, here now I'm going to say natural log of x plus 3, and I'm evaluating this from, I'm evaluating it from 1 up to 19 over 7. Now, I must show you why this part and that part gives you natural log. I'm going to try and do that as quickly as I can, because time is really not on our side in these questions. We have answered only 2 questions, but you can see, and we're not done with the second one. You can see how much time already. It's 25 minutes. So let's look at, I must now show you why 1 over x minus 2 it gives us this as the integral. So we're saying the integral of 1 over x minus 2 dx, and I'm saying this equals natural log of x minus 2. So we're going to say here, let u be equal to x minus 2, du will be dx. Now come back here, this integral will change to 1 over u, and instead of dx, I'm going to have du. What is the integral of 1 over u? You remember this from the previous videos, that this is just natural log of u. And what is u? There it is. It gives you natural log of x minus 2. Now, I want to challenge you, do the same. You will see that the integral of 1 over x plus 3 dx gives you natural log of x plus 3. If you do the same technique, u-substitution. Now let's plug in the numbers and simplify this and see where it takes us to. Now, so this is going to be, we're here now, this is going to be equal to minus, and I'm going to start with this part here, 19 over 7 into that place, natural log of 19 over 7 minus 2, right? This is actually positive because that will be 14 over 7. So this is positive. I don't have to use absolute value signs now. And then it has to be minus, and I must put 1 there now. So it will be natural log of, and this now is going to be 1 minus 2, which will be minus 1. I need the absolute value signs, absolute value of minus 1, like so. I'm done with the first part. And then I'm going to have to deal with this part here. So let me write it down here. I'm going to say plus here. This part here, I'm going to say natural log of 19 over 7 there. It's going to be positive 19 over 7 plus 3. And then I'm going to say minus. Put 1 there. It will be natural log of 4. 1 plus 3 is 4. Natural log of 4. Now, so we have to simplify that and this, and then we're at the answer. Let's look at page 8. How does it work? The first part is going to be equal to, so the first part is this part here. I'm going to simplify that first, because this one here, this is 21 over 7, as you can see. I want to make denominator the same. That will be 19 over 7 minus 14 over 7, and this is the natural log of 1, because absolute value minus 1 is positive 1, and natural log of 1 is 0, so this is gone. I'm just having that one here, which is minus, and then I'm going to plus that, and then minus natural log of 4. So what I have now is, check this out, I now have minus here, natural log of 19 over 7 minus 14 over 7. That's my minus 2. And I'm going to say this is positive, and then this is gone, and I'm going to have plus. This part here, I'm going to say natural log of, check, this one is going to be positive, so I have to have round brackets, 19 over 7 plus 21 over 7, and then minus natural log of 4, that one there at the end. Right, let me put this one aside now, because we're almost there. This one here, you check it, this is going to be minus natural log of 19 over 7 minus 14 over 7, and 19 minus 14 is 5. I think, yeah, 5 over 7. So natural log of 5 over 7, like so, plus, what is this? Well, this is 40 over 7. Natural log of 40 over 7, and then minus natural log of 4. I'm going to write the positive term first. So this is equal to natural log of 40 over 7, like this, minus natural log of 5 over 7, and then minus natural log of 4. This part here, I'm going to remind you of one of the laws of logs. One of the laws of logs, I explained it in calculus techniques of integration 4. I explained that you have natural log of m over n, is equal to natural log of m minus natural log of n. Don't forget this. This form here is that form there. So I need this form. See how beautiful and easy maths is. So if you see this form, that is the one that takes you to the answer. If you see this form, that's the one that takes you to the answer. Now, in this case, we have this form, and therefore we need this form. So I'm going to have to divide these two terms here. So I'm going to say this is natural log of 40 over 7 divided by 5 over 7, like so, and then minus natural log of 4. Now, what is this? Natural log of this one here, if you divide it, it's going to give you 8. The 7 goes up, 5 comes down. The 7's cancel, 5 into 40, natural log of 8. That's what you have. And then you have minus natural log of 4. Applying this law again, you're back in that form. This one here, it means 8 and 4 would divide. So this is going to be natural log of 8 over 4. And our final answer is natural log of 2. That's the final answer to our second integral. In this video, I'm going to cover only 2 integrals because I already am over 31 minutes from the start. So these are cases, extremely higher order cases of u-substitution. Just 2 definite integrals we've gone through today. The first one was just typical u-substitution advanced case. The second one was the partial fraction decomposition. In my next video, I want to move to trig substitutions and so on, and then we will look at combinations of all these probably in one question or 2, and then we'll move to determination of limits and further aspects of calculus 1 and 2. All right, if you're new to this channel, please support us by subscribing and inviting friends to subscribe. Share these videos. We really appreciate your support and your feedback in the comment section below. Yeah, I try very much to respond to each and every comment and clarity seeking question and so on. All right, see you in the next video.